Hello everyone and welcome. Today we'll explore blockchain technology, a revolutionary way to record, verify, and transfer information in a secure, transparent manner. Blockchain is essentially a decentralized ledger that allows multiple parties to record transactions without the need for a central authority. Think of it as a continuously updated digital notebook that everyone trusts.
Today, we're getting into a revolutionary technology that's changing how we think about digital transactions, blockchain. Now, whether you've heard of it in passing or are deeply involved in tech circles, this video will clarify what blockchain is, how it works, and why it's so groundbreaking. So let's get started. So what is blockchain? Blockchain is a transaction record database that is distributed, validated, and maintained around the world by a network of computers. So instead of a single central authority, such as a bank, a large community oversees the records in blockchain, and no individual person has control over these records. Blockchain is based on decentralized technologies, and this functions as a peer-to-peer network. And blockchain can be defined as a peer-to-peer decentralized distributed ledger that records transactions efficiently and in a verifiable and robust fashion. So some real-life examples would be records of sale and purchase of raw material, bank account statements, or some Excel sheets tracking hospital equipment, right? So imagine a traditional book-based ledger. Now think of blockchain as the book, right? The entire blockchain is the book. So in this digital version, the book is the entire blockchain. The pages are blocks in the blockchain, right? And entries on a page are transactions recorded in these blocks, all right? So you see here, each page refers to a block connected to the previous page through a page number. It is easy to detect if a page or block has been removed or deleted, and it's easy to arrange the pages and blocks and identify suspicious activity because of the page number. It is impossible to tamper a previous entry in the ledger without someone noticing it, as the pages and blocks are built tightly on top of each other, okay? Now, each block is connected to the one before it, similar to how pages are numbered in a book. This makes it easy to detect if the block has been altered or removed, ensuring that all records are secure and intact, okay? So unlike a centralized system, such as a bank here, right? Blockchain is maintained by a network of computers around the world, and the network operates on a peer-to-peer basis, making it decentralized. Every transaction must be validated by this network, ensuring no single person has control over the records, right? So a little bit of history. Scott Stornetta and Stuart Haber in 1991 proposed the concept of a secured chain of blocks, or set of records. Later in 2008, the blockchain system was conceptualized and introduced by an individual or a community known by the name Satoshi Nakamoto. And they implemented the idea of using hashing in the blockchain framework to make it so safe that once saved in the blockchain, no one can make modifications or erase the data. This blockchain architecture is used by the Bitcoin cryptocurrency system as its basic or foundation infrastructure. No one knows who Satoshi Nakamoto is. It could be a person, it could be a group of individuals. No one knows. This person chose to keep themselves anonymous, all right? So here's what happens when a transaction is made, okay? All right, first the transaction is requested, all right? Transaction happens between X and Y individuals. Then this transaction is represented online in a block, okay? Then it's broadcasted to a network of peer computers known as nodes, and anyone can choose to be a node. They just have different requirements depending on what blockchain network you want to be a node on. These nodes validate the transaction, okay, here. And the user's status using known algorithms like secure hashing algorithm 256 in the Ethereum virtual machine, also known as SHA-256. A verified transaction can involve cryptocurrencies, contracts, records, or other information. All right. Now that block is then added to the existing blockchain and the transaction is complete. So that's how blockchain works, right? So now each block has certain characteristics, right? Has a block version, Merkle tree hash, previous block hash, the in bits, nonce, timestamp, and then the transaction count. Okay, so this is what a block looks like. So to illustrate this, let's bring over the mempool. So this is the Bitcoin Explorer, right? So if you look here, you'll see where these blocks have been generated this much time in the past, right? So you'll see right now we're on block 848,522, and whichever one of these blocks gets mined next, more than likely this one, will be on block number 848,523. All right. If you come down some, you can see transactions involved, the amounts that were involved. Okay. These transaction IDs are the transaction hash. All right. And you can even click on that and get into more detail regarding what happened in this particular transaction. All right. And you can see the inputs and outputs, what was involved, how big it was. Okay. Let's look at Ethereum. All right, the Ethereum virtual machine, which a lot of other chains were built on, like Avalanche, Binance, Chronos, you'll see that in their transaction flow, the latest blocks here, latest transactions. So let's look at a block now. Let's look at block number 20,120,166, okay? And you'll see some of the same information, block height, the status that it was finalized, the time, when it was proposed, the transactions, withdrawals, the fee, who got the fee, the block reward. All this information is involved in the block, as well as what all transactions took place. So there were 86 transactions in this block. And we can also go to the Algorand block explorer, allo.info, okay? And let's just type in let's say a popular token. Let's not look at Cycle today. Let's look at Algorand, since it's the Algorand network, and this is going to be the cryptocurrency for this network. Let's see, Algorand projects, accounts. This isn't what I want. Tokens. Here we go. Algorand token. All right. You can see here, you can see an overview of the token itself, the holders, also transactions. So let's look at transactions, and you can see, here we go. All right, here's the block number, sender, receiver, amount. Let's go to the transaction ID here, and you see some of that same information. All right. So basically, that's what a blockchain is. It's a historical record of transactions that took place in a chain, right? So you'll see some of that same information here. So on a blockchain, this is the first block of that chain, and all the information from this block, which is really nothing, goes into this next block, all right? And then all this information goes into the next block. Then all this information goes into the next block, right? So that we get a chain of blocks with all of the information in them. So the genius of blockchain lies in its use of hashing, right? Once data is recorded on a blockchain, it cannot be altered without altering all subsequent blocks in the collaboration of the network, making it virtually tamper-proof. Now, a person could, let's go back a few pages, a few slides, okay? A person could, let's say this person here, let's say she wanted to put in some fraudulent transactions into the network to try for whatever benefit she was going to get out of it. Well, then that has to be validated on everyone's ledger, right? So once these other validators reject her transaction because it doesn't line up with all the other hashing, then her chain starts to move further and further and further away from everyone else's record, which means that she'll eventually be kicked out as a node because she will be the only one with the fraudulent chain, and that maintains the integrity of the blockchain, okay? So that's basically how blockchain works. There are blocks connected together by a chain of hashing algorithms. And like I said, SHA-256 is just one hashing algorithm, which stands for secure hash algorithm, okay? 256 bits. And that's usually what you see on the Ethereum virtual machine blockchain. So that's blockchain in a nutshell. Some of the benefits of blockchain is that there's no central authority. Like we said, it's decentralized, so there isn't one person or group that can control it. It's verifiable and auditable, as we just showed on the Block Explorers. And if you go and check out some of my other videos, I have a video on here about how we detected fraud in an airdrop by using the this actual blockchain here by searching for transactions with an airdrop that we had, where we had someone saying that they did not receive funds that they in fact did receive, and then sent out of the place that we sent them to another place. We were able to track all that. Okay, so it's verifiable and auditable. Okay, there's no need for any type of third party or intermediary. You know, when you're using an intermediary, someone between you and the person sending you money, or the person you're sending money to, they always want to collect a fee. So there's no intermediary need. So there's disintermediation of blockchain. Okay, so we cut out the fees, so it costs less overall. And some might argue that this is going to put the middleman out of a job, but I would be hard pressed to find the person that still wants to ride a horse around town when there's all these cars, or the person that wants to, hand wash their clothes when we have washing machines now. I mean, even me as a blockchain developer, I'm looking at AI and I do use it, and I'm thinking maybe I need to start moving around, because I can see a time when these programs start to program themselves and my work become obsolete. But until then, we'll just keep on doing what we can to make life more efficient and more manageable for us all right. There's also the confidentiality and integrity of it. Okay, and also its robustness. Like I said, it's a lot more efficient, it's a lot faster. It cuts out a lot of unnecessary steps that we have in a lot of our transaction flow today.
Tokenization is the process of converting physical or non-digital assets into digital tokens on a blockchain. In our case, this means representing real estate assets like houses, buildings, and land as digital tokens. Imagine owning a share of a prime commercial building through tokens rather than needing the full capital for a whole property. Today, several innovative projects are already using blockchain for real estate. Investors can now easily buy, sell, or trade property tokens, making the market more accessible and dynamic. As blockchain technology matures, we expect even more integration with traditional finance. This will lead to increased liquidity in real estate markets, lower entry barriers for investors, and improved market efficiency. Regulatory clarity will further boost investor confidence and drive innovation. To illustrate how this works, I'll now demonstrate NFT smart contracts that represent a house, a building, and land. These NFTs are digital proofs of ownership that can be transferred on any EVM-compatible blockchain.
Okay, so now illustrate how all of this works. I will now demonstrate NFT smart contracts that represent a house, a building, and land. These NFTs are digital proofs of ownership that can be transferred on any Ethereum virtual machine compatible blockchain. And I chose Ethereum virtual machine for this demonstration because it is the most resourceful. And once you set up your code on Ethereum, you can point it at any compatible blockchain. You can point it at Binance, you can deploy it to Avalanche, you can deploy it to Polygon, to Base. So I like Ethereum for demonstration purposes and for those reasons. However, if a blockchain is NFT compatible, if it has resources for NFTs, doesn't matter if it's Solana or Sui or Algorand, you can make NFTs too. The coding will be different, as those blockchains use different coding and programming languages. So we're just going to use Solidity, TypeScript, JavaScript, and Hard Hat for our development environment. So we'll go into our contracts here. All right, as you see, I have house nft.sol, which lets us know it's a Solidity file, and I can name it whatever I want. Okay, and we'll see here that we are using Solidity version 8.0, and we're importing. This is very important, the import here. We're importing Open Zeppelin's contract token ERC 721 extensions for ERC 721 URI storage. Okay, now URI is a unified resource indicator, right? You're used to seeing unified resource locator URLs when you're on the internet, and that's pointing you to the address of different assets that are available on the internet, different packs of data. URI is going to be for the interplanetary file system, which is where we store metadata in JSON files, which I'll get to that in just a minute. But the point of this is this. By importing, this import statement here makes it so that the rest of our contract here already is in alignment with this contract here. And we can find it as a package, as a dependency that I had to install when I created this project. But when we come down to Open Zeppelin and just follow the path, token, ERC 721, extensions, storage. All right. This code came pre-packaged. I just had to install this dependency, right? So when we talk about dependencies, we're talking about our package.json file here, which tells us that we're using Open Zeppelin contracts as a dependency along with Nomic Foundation's Hard Hat tool, okay? Hard Hat is for development, testing, and coding purposes when you're actually building something, okay? So we'll go back to our contract here. So this is a smart contract. When you hear of a smart contract, it's really just saying that it is a code that is sitting on the blockchain waiting on something or someone to interact with it. And how are we interacting with it? We are calling the functions, all right? So we set up our contract, house NFT is ERC 721 URI storage. That's kind of like inheriting, not kind of like, it actually is inheriting from the Open Zeppelin contracts token folder that we just looked at a few minutes ago. So everything that's a part of that is now a part of this that we're building on top of it, okay? So our number, unassigned integer 256, public token counter. All right, we're just setting our variables here. We're declaring our variables anyway, and they're going to be public. So everyone's going to be able to see the token counter on chain. Okay, we could make this to private and it would only be visible to the deployer, but it's going to be visible publicly. Okay, our constructor is a function that's called only once just to let the blockchain know what kind of contract this is. Is it going to be a token contract? Or is it going to be an NFT contract? So NFTs are using standard 721 right now, and we can make as many as we want. Remember when we talked about fractionalized shares? We can make this 100, or we can make it one. Only one person can own, or 100 people, or 1,000 people, or however many people you want. All right. Now these sections are commented out. All right, and also notices to let us know what's going to be happening with each part of this. So when the mint function is called, the parameters of address, all right, and the token URI, which is produced when we upload our metadata JSON file to the blockchain, because that doesn't exist inside of the smart contract. And what am I talking about? Let's see, what I'm talking about is the property metadata here. So you may notice this is a little bit lacking as far as all the details that you might want with your house. So we'll go here, and here we have an elegant family home. This is the metadata. This is what would show up when we call that URI storage function. All right, the description of it, the picture of it, which we would also put on the interplanetary file system as a hash of its own, so that this address would be something like https / let's just say IPFS.com / and then instead of having all of this, we would just have, whatever that hash is, and it could be like anything, right? It could look like that. That would be the hash for where the address of the image is. So whenever that metadata is called upon, it'll produce that image, right? But I'll just keep it as example for example purposes right now. And then we have our different traits, right? Property size, the bedrooms, number of bathrooms, acres, address, coordinates. We could have owner history here, and we just follow this same format, right? A JSON file has to be housed inside of these curly brackets, and then this basically this syntax here, okay, and this structure. But we can add whatever trait we want, okay, and that's how that would look. So we'll go back to our house nft.soul. So when we call on mint, it'll call on the URI that's going to produce that JSON file's information, all right, and it's going to return a number, all right, some unsigned integer for the token ID. That's going to be the actual NFT contract address, and then the token counter, and then this is all a part of the mint function. Now, where would a user see the mint function? Well, they would see the mint function here, all right, when we go here, and this is on localhost 3000, so this only exists locally on my computer right now. This is how it looks when we are building these apps, okay? And you can see here, I have this set up here, and then when you go to mint, when you go to hit this button, it's going to call that function. So of course, first thing you would do is connect the wallet, and we'll disconnect for now just to show how that works. So let's take this off screen again for just a minute. All right, and you can see how the mint function is here. Now we could name that anything we want on the other screen, but let's go to our front end, which is our user interface here. Okay, and we'll go and find the actual page layout for the home page. All right, okay, and you can see same thing. Welcome to the future of real estate tokenization. This is your custom home page and all of that. Same thing we saw here. Okay, right? Now, as far as the other parts of it, we're importing that the same way from other code that we have established here. Like, let's look at our wallet connection, right? We'll go into our components and connect wallet function here. We'll connect wallet file, and we'll find all the functionality needed to connect our wallet. Whenever you're using client, whenever you're doing things on Next.js, you have to have use client at the top for it to know that it's going to interact with the user interface, is what the user is going to use. But here's how our blockchain connection takes place wallet wise. Window Ethereum is just a way to, it's like a portal that the regular internet web 2 browser interacts with blockchain components of the internet, right? So we would just, set the account, find the state of the account, if there's any errors, and then we have to find, so say if it comes back as undefined. So if the type of window does not equal undefined, then we'll go, and the window is Ethereum, then we'll request to go into the account, right, to open up the wallet, or else it's going to throw us an error, right? And so then it'll say, please install MetaMask. If not, or it will connect, right? Or it will tell you connection failed, and then we can disconnect through all of these disconnect handling functions here, all right? And this is telling you when you click it to do this, when you click it to do that. So when we go here, right, and we want to connect our wallet, we'll just hit click, connect wallet, and then the wallet will come up here. I'm going to take this off screen. Well, I already put my passcode in earlier, so I don't need to do that now. So let's just use the core wallet here, and you'll see here it's now connected to that core wallet, which is in my browser extension here. All right, so I'm now connected there, and I'll disconnect by just clicking the disconnect button. Now I'm disconnected. So what a user would do is connect their wallet, mint their house NFT, by entering the token URI or the IPFS URL that we talked about earlier. And basically, I mean, that's it. Now the house exists as a tokenized asset on the blockchain. Okay, so this is happening with houses, it's happening with cars, it's happening with personal identity, it's happening with money, US digital coin, the digital euro. All of those are tokenized real world assets. They are computerized versions, digital versions of something tangible, right? And we could do the same thing with, let's see, go back to our contracts. We can go do a whole building, right? It's essentially the same code here, right? Essentially the same. We're just doing it as a building, right? We just change the contract name. It's going to give us a different contract address when we deploy it. And the same thing for land. What changes would be the JSON file, right? Let's go back and find that. So for the building here, and you put whatever you want. It's the same structure, just different descriptions, right? Total number of floors, maybe the total area, maybe the location, maybe the year built, last inspection, and you can update this, which is why we don't store it on chain. We store this off chain, just so it can be changed, right? Because once something's put on chain, it's first of all, it's expensive to do that, and then once you put it on there, it's kind of hard to update, right? If not impossible, depending on how it's set up, whether directly or through some sort of proxy. And this is the same for land, right? Location, zoning, access. You could put your coordinates in here if you want to, and then you'd have tokenized land. So how do we get it from the computer onto the blockchain then, right? Well, then you have to have these deployment scripts, okay? And this is basically a function that we run through our terminal command line by running this command here, right? So what we do, when you go into your search, you would click type terminal, and then something like this will come up, okay? So this is actually the directory that I have all of this in. And if I wanted to deploy the building NFT, I would just type that in there and point it at the network for Ethereum and hit enter, and it would send it out as a broadcast across the internet, right? And that would hit the blockchain on whatever network I want to send it to. Now, how do I set up my networks to send it to? Well, we just come over here to our hardhat config.js file, and we see here the networks that we're ready to send to, right? We have so far set up Ethereum, Binance Smart Chain, Polygon, Avalanche, and that just goes through their mainnet RPC URLs, right? And where do we keep that? Now, we keep all of these things in a .env file. And the .env file is a file for privacy. I'm going to go ahead and show you this .env file because I don't have anything in here that I wouldn't want anyone to see. But as a developer, you never show this file when it has the real information in here. Like if I had the NFT address, or if I had the building address, or especially the private key, all right? Especially the private key. And you see I have private key. And as I say, it's code, so I can just, change it, and now it's private key. If I had tried to run that function with that error, it would have threw an error until I came and figured out that I actually needed to put a T in there would be the cause of the error. But you're basically interacting with the network's connection points, right? So when I get ready to deploy these smart contracts, I can put them on any blockchain I want that's Ethereum compatible using this same code by just changing the network that I'm sending it to, because I already have them configured inside of my hardhat config.js file. All right. And then there's tests here. All right. We test our smart contracts to make sure that they do what we want them to do. Right. So we don't know until we actually put it out there what it's going to do, but we have a pretty good indication. We feel pretty safe about putting it out there, at least on a test network, if we can see that, when we put it out there, it passes these tests. Now, we test it based on the standards set up by Ethereum or Algorand or Sweet or whoever. They have certain setup, a certain structure that the smart contract has to follow in order for it to work. So we set up that structure in our original contract, and then we test that structure against itself to see if it at least works how we think it's going to work. And then once we do that, we deploy it to a test network so that we can interact with it live without it costing any real money. And then once we see that it's working well live, then we deploy it to the mainnet and everyone can use it. And hopefully there's no bugs from that moment on. Okay, so that's pretty much an overview of what a real world tokenized asset would look like on the technical level, kind of giving you a behind the scenes look at how these things are put together and how they work. All right, so again, these are the smart contracts here in our contracts folder, and we could name this, Blueberry if we want to, but it's kind of hard to keep up with because it becomes a lot when it's called Blueberry. But there is a lot of work, a lot of logic, a lot of time goes into building these applications. Of course, when we as users get them, we generally just want it to work, right? We want to point, click, make it work, right? When I click on mint NFT, I want it to mint NFT. I don't want to give me any kind of an error, right? When I click on this box, I want to be able to type in here. I don't want it to be spinning forever and say error. So that's what us developers work on, making sure that the interaction for the user is as seamless as possible. So most of the time with coding is spent with solving problems, fixing bugs, because it doesn't just show up as a finished product. It's a long process of basically just weeding out the problems, really. And sometimes we just have to walk away from it for a while and go and do something else, because it can get really frustrating. You have to have a lot of patience. But there's, like, as you can see, there's a whole lot that goes into this. But the world is moving towards real world asset tokenization. Is the whole point of this presentation, is to show the back end, some of the background of how these things work.
By combining smart contracts with a sleek, responsive front-end, blockchain technology is forging the future of real-world asset investment and management. Each NFT minted represents a tangible property asset backed by immutable blockchain technology and enriched with detailed metadata stored on IPFS. This empowers investors to gain fractional ownership, enhanced liquidity, and unparalleled transparency in tokenized asset markets. Embrace this journey and continue learning, exploring, refining, and innovating. The future is decentralized, and you're at the forefront of this revolution. Congratulations again on taking your first transformative step into the future.